Let's talk about electricity. What is electricity and why is it so useful? There are mainly two forms of electricity, static electricity and current electricity. Out of these two, current electricity is the one we use on a daily basis. It is the one that is responsible for the simplest light bulb in our home to the most sophisticated computer in the world. So how do these clever devices do what they're supposed to do? These devices have paths through which electrons travel with tremendous speed. These paths are what we call electrical circuits, and they're composed of closed loops. By that, I actually mean any kind of loop. For example, a circle and a rectangle are closed loops. If these paths were open, flow of electricity would stop immediately. Closed loops are absolutely necessary for electric flow. A single circuit can contain multiple loops as well. Complicated circuits can have hundreds and thousands of these closed loops. Our objective of this course is to build up a few techniques or tools that will enable us to analyze any electrical circuit in general. That means we will be able to predict how a given circuit will behave no matter how complicated. But to be able to do that, we will first have to learn basic electrical quantities. The first electrical quantity I'm going to talk about is charge. Every phenomenon related to electricity or magnetism can be traced back to this one property called charge. Charge is a property of matter, specifically subatomic particles, just like mass. But unlike mass, it comes in two flavors: positive charge or negative charge. By now, it is common knowledge that everything around us are made up of atoms. These atoms contain particles called protons and neutrons in its center, and electrons which are continuously orbiting around them. Neutrons don't have any charge, but protons and electrons do. In fact, protons carry positive charge, whereas electrons carry negative charge. But how much charge do they actually carry? Like we measure mass in kilograms, charge is measured in coulombs. Positive charges have positive coulomb values, and negative charges have negative coulomb values. But positive or negative 1 coulomb is quite a large amount of charge. Electrons have a charge of only negative 1.6 times 10 to the power minus 19 coulomb. Protons have the exact same amount of charge except it has a positive value. This tiny amount of charge is in fact the smallest charge that can exist freely in our universe. Since we work with electron and proton's charge very frequently, we often abbreviate this particular value with E. That means proton has a charge of positive E and electron has a charge of negative E. So protons and electrons have very tiny charges. Then how do we create a charged object whose effects we can actually feel? Well, every object is made up of atoms, which contain equal amounts of protons and electrons. That's why objects usually don't have any charge. But if we take away a few electrons, a charge imbalance will be created and the object will become positively charged. If instead we take away some protons, the object will become negatively charged. But taking away protons from an atom's nucleus is considerably hard. Although we could achieve the same effect just by adding a few electrons. Charge is a conserved quantity just like mass, meaning charge can neither be created nor be destroyed. All we can do is take apart already existing charges. So this is kind of the only way to create charged objects. As a result, any charged object must have a charge that is an integer multiple of E. But just one charged object by itself doesn't do much. If we want to observe the effects of having charge, we need more than one object. For example, oppositely charged objects attract each other, whereas same type of charges repel each other. In fact, This interaction between charges is the phenomena that led us to the discovery of charge. When a negatively charged object is put near a positively charged object, both of them apply a force towards each other, which is the attraction I just mentioned. But instead of putting a negatively charged object, if we took a positively charged object, the direction of the force would have flipped, causing them to repel each other. Same phenomena is observed in the case of two negatively charged objects. What's amazing is that when these charges interact like this, we can get some energy out of it. That's what we will discuss next time.